Now we're going to go through some examples that deal with finding antiderivatives. It's find the general antiderivative of the following function. So it tells us f of t is equal to, let's see, 1 plus t squared divided by square root of t. You had something similar to that on your second test. It was one of the first take a derivative problems. A lot of you guys did the quotient rule, when instead you should have been doing the power rule. Okay, so we're gonna want to do the same thing here. You look at this, you think it's a quotient. How do you want to do a quotient? Well, that's something you'd learn in Calc 2. Okay, so you got to do something different. You cannot take the antiderivative of a quotient with the knowledge you have thus far. So let's go ahead and rewrite this. Remember, square root functions are the same thing as 1/2 powers. So right here, 1 divided by t to the 1/2 power plus t to the first divided by t to the 1/2 power plus t squared divided by t to the 1/2 power. Well, this is t to the negative 1/2 plus 1 minus 1/2 is 1/2, so this is t to the 1/2 plus 2 minus 1/2 is 3/2. Okay. So this is my simplified function, okay? Now what we want to do is find the antiderivative, big F of t is equal to, undo these power rules. Go up 1 power. Negative 1/2 plus 1 is positive 1/2. So this is t to the 1/2 power. And then there's a 1 out in front of here. Same with here, same with here. So it's going to be 1 divided by, I'm going to divide by the power, 1/2. Okay? 1 divided by 1/2, I'm going to tell you is 2. So this simplifies to a 2. I don't want to write another line. I'm already running out of room. Here, plus, go up 1 power. 1/2 plus 1 is t to the 3/2. Now you divide by this power, 1 divided by 3/2, that's going to give you 2/3. Okay, so a 2/3 is going to go out front here. Plus t, 3/2 plus 1 is 5/2. And if you notice a pattern with this, since all these coefficients are 1, when you divide by this power, the coefficient out front is just the reciprocal. 2 over 1 is 2. 3/2, 2/3. This one is going to be 2/5. You do get a 1 divided by 2/5, but that's just because all of them were 1. We can notice that pattern. And in fact, if you have a fractional power, you could, instead of doing a division, you could do a multiplication by the reciprocal. Okay? It's another way of thinking about it. So I'm not done here. Plus c. So right here is the antiderivative of this little f of t. We use the power rule by simplifying this function, getting it out of the form of being a quotient, a long quotient. Okay? So now let's do another example. R of theta. So theta here is our variable, equals secant theta tangent theta minus 3 to the theta. So this one we don't have to simplify. I'll call it big R of theta is equal to. Now you have to think to yourself, if I were to take a derivative of a function, this is a trig function, so the antiderivative should probably be another trig function. If I were to take a derivative of this trig function, what derivative would give me secant tangent? Now, if you look at that table of antiderivatives, secant tangent is on there. The antiderivative of secant tangent is secant of theta. Okay? So if I were to take the derivative of secant of theta, I should get secant tangent. Now we still have a minus here. Now that is a power, or not a power function, an exponential function. If you recall, the derivatives of exponential functions are themselves. So let's see, if I were to take 3 theta and I were to find the derivative, it'd be 3 theta, you copy it, times the ln of the base, 3. So going backwards, it's going to have the same thing, 3 theta, but instead of multiplying by ln of 3, I'm going to divide by ln of 3. Now, if this was an e, you would be dividing by ln of e. ln of e is just 1. Okay? So that's why you didn't see it in an earlier example when we found the antiderivative of e to the x. Okay? Now, if you were to take the derivative of this, you're going to see the ln of e with, or sorry, the ln of 3 and the other ln of 3 will cancel. You get 3 to the theta, and then we already talked about that. Now, plus e. Don't forget the plus e. Okay? Very important. Okay, so there's a problem for you to try. Go ahead, pause the video. When you're done, check your solution, see how you did. Resume the video. Now, we're going to go through another example. This example gives you an initial condition, okay? This allows us to solve for the value c. So it tells us little f of x is equal to, looks like a minus sign, 5x to the 4th minus 2x to the 5th. And then they tell us big F of 0 is equal to 4. They're telling us a point on the graph of the antiderivative. The point is 0, 4. So let's go ahead and find our antiderivative, big F of x. Undoing the power rule right here, I go up 1 power, 4th goes to the 5th. I divide the coefficient by this power. You get 5 over 5, 5 over 5, simplifies to 1. Minus, go up 1 power, x to the 6th, 5 going up 1 power gives you 6. And then I divide the coefficient by the exponent. You get 2/6 there, which simplifies to 1/3. Now, what I'm going to do here, don't forget the plus e. What I'm going to do here is plug in the point and solve for c. Now, this one's very easy. We could do it with a different point in a second, but if I plug in 0 here, so f of 0 is equal to 4. That means plug in 0 into here, set it equal to 4. Well, 1, 0 to the 5th power minus 1/3, 0 to the 6th power plus c is equal to 4. Well, that's 0, you get c is equal to 4. So, now that we know what our c value is, this is the antiderivative that satisfies this initial condition, okay? Now this one turned out really easy because we had a 0 here and there's a power function. All the zeros go away. Let's tweak it a little bit. Let's make it a 1. And let's see how our constant is going to change. So we're back to plus c. We know, let's see, we're changing it to 1 now. We know f of 1 is equal to 4. What this means is plug in 1, set it equal to 4. 1 times 1 to the 5th power minus 1/3 times 1 to the 6th power plus c is equal to 4. Well, this is 1 minus 1/3 plus c is equal to 4. 1 minus 1/3 is 2/3 plus c is equal to 4. And then lastly, if I subtract 2/3 on both sides, c is equal to 10/3. So now we know that this constant should be 10 over 3. So now with a different initial condition, we came up with a different C value. And that's going to be true for every different initial condition you give it. It will come up with its own unique C value. Now, I only changed the x. I could change the y, and that will produce a different C value. But this is how you solve for the C value if you are given a condition. Okay, it's very simple. Just plug in your number, plug in your x values, plug in your y value, and solve for C. Okay.